This conference will now be recorded.
Good morning, friends. Welcome to GoOnlineTrainings.com. We are discussing about incremental loading, called as delta loading, and will be people will be calling this as a partial loading, whatever you wanted to call them as, we can call it. And we had seen couple of patterns, right? How can we use lookup? How can we use SCD? How can we use merge statement? And we can also write, a lot of joins, except this one, that one, lot of things we can do it, and we should be able to perform, incremental loading. So lookup is good when you have so much of a caching, and SCD is also good. It is ready-made transformation, and it can perform incremental loading for the small data sets, not very large data sets, right? So the question is that when you have so much of a data, for example, I have 200 million data in the destination. Okay, if you have 200 million data, can I compare 200 million data with the lookup? Because what are we doing in the lookup? If you observe carefully, if you observe carefully, let me go to my lookup transformation, right? My lookup or merge, what are we doing? We are getting data from the destination table here, right? Dim employee table data, destination table data we are getting, and we try to compare with the source data, right? So that is how we have configured. So this is the destination table data. But the question is, if you have 200 million data in the destination table, so can we, compare row by row by getting the data from the source and destination? So can you get a 200 million, 300 million data, and can you load all the data into the full cache? It is not going to work, right? So even lookup is good, because lookup also get all the data from the source and destination. It has to map, right? So mapping, 1 million data from the source and 200 million data from the destination table, and comparing with this data is completely difficult. So lookup will fail when you have large amount of data. Even, SCD is going to be failing when you have large amount of data. Even merge statement is going to be failing. Why? Because if you have, uh, let me go to your merge, right? So I think merge is implemented in merge DB. We had written a stored proc yesterday, right? If you see the stored proc, so what is that doing in the stored proc? We're comparing employee ID to employee ID. Which employee ID? Source employee ID to destination employee ID. Then that is one thing. The remaining columns also we are matching, right? So it's not so easy when you have a 200 million data in the destination table and try to map. You have some 50 million data in the source table, right? So definitely merge is also going to give you a lot of issues when you have too much of a data, right? So see, now we are comparing source employee ID to the destination employee ID. Do you think that it's very easy if you, when you have 50 million data in the source level and 200, 300 million data in the destination level? Is it very easy? It's not so easy. And for the updation, we're matching the employee ID primary key column, and remaining columns also we are trying to match it. If you have 500 columns, and if you have 200 million data and matching column by column, row by row, do you think that it is very, very faster? Now, even for this condition, merge is also going to fail. But only the thing is that merge does not need any kind of a full caching technique. Clear? If you have a caching techniques with the lookup and everything, either you can go in for a no cache mode in the lookup, or we can simply ignore lookup and try to implement the incremental loading with the merge, which is supported in Oracle SQL Server many of RDBMS. Am I clear? But in the merge statement, when you have a large amount of data, again, merge is not going to be very, very faster, because it's going to be comparing the primary key columns. So if we have 50 million data in the source and the 200 million data in the destination table, then comparing row by row is very difficult. Okay, that is one thing. For the updations, we're going to be mapping, the primary key column and remaining columns also we're mapping here, whether remaining columns are matching or not matching, right? If you have 500, columns are there, 200 millions data is available, and you need to write so much of a code in this. We had written only 2 lines of code, 2 columns, but we have 500. If you have a 500, columns, and you need to write too much of a code, and if you have, for 200 millions of data in this, you'll go mad. Clear? So merge is also not going to work when you have a bigger data sets. Clear? But how can I perform incremental loading? So that is where Microsoft is giving us one more chance. This is what is called a CDC, change data capture. Clear? So this is going to be, implemented automatically at the database level. Clear? So merge statement and lookup we knew, and we can implement them for the smaller data sets, right? When you have 200, 300 million data sets, definitely without a CDC, definitely it will be very, very problem. Or you may use any other custom solution. Definitely your lookup will fail, your merge will fail, your SCD will fail when you have large amount of data sets, right? So I'm talking about 200 million data in the destination, and we have 20, 30 million data in the source. Am I clear? So definitely those incremental, strategies will fail. So that is where Microsoft CDC is implemented initially at the Oracle level. Clear? Even merge is implemented initially at the Oracle level. Then Microsoft is taken the same concept. CDC means change data capture. Change data capture. This is implemented initially in Oracle and other databases. Even SQL Server is, taken this, technology. So this is implemented almost 12, 13 years back in SQL Server, and 2018, 2008, that is where the CDs is implemented. So it is going to be using a transaction log. Okay, because whenever you update the data in the source system, whenever you delete the data in the source system, it is very, very difficult which row is got inserted, which row is got updated, right? When you have so much of a data. So what normally we do, we'll take the primary key and we're going to be comparing with the, destination table. This kind of a technique is very, very difficult. Clear? When you have large data means I gave you source is having 20, 30 million data, destination is having so 100, 200 millions of rows in the destination table. Clear? If you wanted to perform an incremental loading, the simple lookup will fail, the merge is going to be failing, anyhow acid is going to be also failing. We cannot implement them. So that is where we are going to use CDC, change data capture. Now CDC is introduced in SQL Server 2008. So you have some things that you need to do it. So CDC, if you wanted to implement, first you have to go to the SQL Server and enable the CDC at the database level and enable the CDC at the table level. So these are the two things that you have to have it clear. If you're doing it the Oracle level, again Oracle supports CDC. You have to enable the CDC at the database level, this level. CDC is now supported for SQL Server 2017 Linux, right? SQL Server 2019 on Linux, because we knew SQL Server can also be installed not only in Windows but also Linux operating systems, right? So what are the Windows operating systems? Windows 7, Windows 8, Windows 9, Windows 10, Windows XP. All these are flavors of Windows, right? What are the flavors of Linux operating systems? So many people would have, seen this. Ubuntu. Ubuntu is what? One flavor of, Linux operating system. Ubuntu. Then we'll say Red Hat, right? Then we have CentOS, right? Like that, we have lot of flavors of are available with the Linux operating system. We have Windows XP, Windows Vista, Windows 7, Windows 8, Windows 10. These are the flavors, right? So Linux also got a lot of flavors, right? So we are going to be using Linux flavors to install our SQL Server. Clear? SQL Server can also be installed in the Linux operating systems, right? SQL Server earlier was not supporting Linux operating system, but later, I think 2017 or 2014 onwards, we could install Windows. We could install not only in Windows but also in Linux flavors. Okay, Ubuntu, Red Hat, CentOS. Because I told about Hadoop, right? Hadoop is going to be implemented or installed in most of the time Ubuntu operating system. So Hadoop needs what Linux operating system. Hadoop also can be installed in Windows, but most of the time Hadoop will get installed Linux with Java. Clear? So Hadoop code completely is written using Java. So Hadoop can be installed Linux and this one. But when we're talking about MSBA, MSBA can be installed on Windows, and Windows will have a .NET software, right? So MSBA, we have SSIS and SSRS and SSAS. Everything is created with the help of a .NET. So Hadoop is implemented with the help of a Java. So when you have Windows, we can install MSBI, and when you install MSB automatically, which is going to be installing .NET as well. Clear? So remember this point. So now we can have SQL Server, and I'm talking about MSBA, right? So all these things can be installed not only in Windows but also in what? And plus Linux operating systems. That is the advancement. Okay, so that you have to know, guys. Here, so you can use Ubuntu, you can use Red Hat, CentOS. Lot of things are available, right? So where you can install your things. Clear? That is the point here. Now CDC needs ADO.NET connection to implement CDC. Am I clear? For example, now the question will arise when you say incremental loading, right? We're talking about some data here, right? So let us say John, and his salary is 1,000, right? His salary is 1,000. How can we implement so all these things? We are using only one technique. So you take this employee ID and you're going to be searching for the existing employee ID. Now, when you have 200 million data, take row by row and comparing row by row, is it very, very easy? It's not so easy. So definitely your merge or lookup is going to be failing, because comparing 200 million and you have 50 million data is very, very difficult. Please, so you should not use, comparison techniques at all. Okay, so that is what is the thing. But how can we know which data is neuro and which data is got updated without comparing? For example, I load this data here, and after loading the data, how do I know this data is got updated or not? So how do I know without comparing? One and one I compare, Angela and Angela I'll compare, 1200 and 1000 I'll compare, then only I'll come to know this row is got updated, right? So that is the technique we are using either in the merge or in the lookup transformation. If you see carefully, what are we doing? We're saying we're mapping. So employee ID to employee ID. For example, one to one, we're mapping. Okay. Then what are we doing? We're mapping name does not equals to name, or salary does not equals to salary. Then you take this as a updated row. So whether this row is got updated or not, we are going to be using this technique. We are lucky we have only two rows, and we are also lucky you have only two columns, right? But you think you have 500 columns, a table can have 1,000 columns in SQL Server. 1,024 columns is the max size. Okay, how many columns you can have per table in SQL Server? 1,024 columns you can have. Okay, if you have 500 columns here, and if you have a 50 million data here, if you have another 500 columns here, and you have 200 million data here, Can we compare row by row, row by row, row by row, and the primary key to primary key, then remaining columns? It is impossible. But how do we know whether this row is modified or not? Right? Without comparing the destination table. So how do we know? So that is where the CDC technique is going to be implemented, right? So CDC is going to create one more table. Clear? So it is going to be creating one more table called states table. Okay. It is going to be creating a table called states table. Clear? So it is going to be having automatic triggers, and it is going to be using automatic log transaction serial numbers. Lot of things it's going to be implementing whenever you modify this row. Okay, whenever you modify this row, it knows that some row is got modified. It's going to be writing into this table. Clear? So whenever the new row comes in tomorrow, whenever the new row comes in here, so it knows that, for example, you insert some new data here. So with the 3000, it is going to be knowing this data is got created. So all the inserts, all the updates, it's going to be capturing into the one more table. Okay, we can also implement similar kind of a CDC, but without having a CDC, we can also implement what normally people are going to be creating. People are going to be using a lot of triggers on these tables. Okay, for example, what they create, I'll tell you. So without implementing CDC, we will come to know which row is got inserted, which column is got inserted. Okay, which row is got updated, which column is got inserted by creating a one trigger on this table. Okay, so for example, so whenever you insert this row, so for example, new Kim is got inserted. Okay. So we create one more table called here employee underscore row update. Something will create one new. Okay. Or we'll say employee underscore changes. Okay. So whenever you insert something here, so the trigger is going to be getting fired, and whatever be the row that is getting inserted there, clear? The row also will get inserted here. Clear? So we knew that what is the neuro came in? The neuro came in is this. How are we able to identify? Because we created a trigger. Trigger automatically will capture this data. It is going to be putting. Tomorrow you're going to be modifying 2 John 2000 to 2500. So this is the updated record. So this record also it is going to be getting here, and it will have a flag here. Okay, it will have a flag. This is a new insert. This is what is called a new update. Clear? So without mapping, without comparing everything, so we can have a trigger on this. So whenever we insert the data here, the new inserted data is going to come here as an insert. New updated data is going to come as an update here. Clear? So without touching this data, this may be having 50 million records. Okay, this may be having 50 million records, and this may be having a 200 million records. We are not going to be comparing this column with this column, this data with this data. We are not touching either this or this. But what did we do? We are going to be implementing a trigger. First thing you should know, what is a trigger? Trigger is a program, so which is automatically gets fired, which it is just like a stored procedure. Clear? It's just like a stored procedure. Whenever you insert the data, whenever you delete the data, the trigger will, so you need to write a program inside the trigger. The trigger is going to be taking the inserted row and storing into one more table, employee changes. We create same structure, but the table name is employee changes, right? So then what we do, we are going to be uh, taking this data, and whenever we insert, the data will get come over there. Then what we do, we implement our solution and read the data from this table, and if it is inserted, you need to take and you got to insert here. Okay, If it is updated, you take this data and you supposed to update it there. That's it. So after doing this, you delete the data from here. That's it. Simple. Clear? So you're not going to be comparing this ID to this ID, this ID to this ID. And if you have too much of a data, comparison is very, very difficult. Tomorrow, you update this record to 1200 salary to, let us say, Angela, is updated with some K. So whenever you update, the updated record is going to come here. Okay. So it will be updated record. And you may be inserting new tomorrow. Bhaskar is the new employee getting joined with the 1400 salary. So this is the inserted. That record is going to come here as an inserted record. Clear? So using this flag, what you do, you're not going to be comparing. You know that, so this has got updated. So this record you take, you're going to be overwriting it there. So because it is updated, this is a new record, it is going to be getting inserted there. After done that, you're going to be deleting all this data from here. Clear? So that is how, by using one more table at the source level or the some staging level, and by adding triggers to the source system, we can implement this kind of a thing. But here the problem is, whenever you insert large amount of data, triggers are automatically fired. We knew that the triggers are going to create lot of performance issues whenever you have large amount of data is going to be inserted or updated. Every time trigger is going to be getting fired, and it may slow down the OLTP system process, right? So with the help of a triggers and with the help of one more table, we should be able to perform incremental loading. So, right? So this can be implemented, right? So without using this, we can use change data capture. So that technique is going to be using a LSN number. So which row got modified. I'm not going to be keeping a trigger automatically, which is going to be storing the transaction log file will be there, right? So when you have a database, every database will have a data file, right? And it will also have a log file. In the log file, which row is getting inserted, which row is getting updated, all the information is going to be stored. When you go to a database called merge, let me show you. Every database will have two files, right? So it is the RDBMS level. We know all these things. One is called, data file. One more is called log file. So what is the purpose of a log file? Log will write the records being inserted, the records being updated, every information will get recorded into the log file. Clear? So every log file will have a log sequential number, something like this. So using this log file, we can recover the data. I told you in the day one class of SQL Server. Clear? So our CDC is going to be using the same log file. Okay, log sequential number, and the log sequential number will be stored in separately, and using that number it is going to be maintaining and calling. We need not create triggers and everything. That is the beauty about it. Clear? So without CDC, if you wanted to implement, you need to write a trigger in this, and you need to create a new table. Updated record, you need to insert here. Deleted record also, inserted records also you need to insert there. And using this table, you should be able to perform the incremental loading. So that you can do it so manually. So that's what I told you, right? So this is one logic, but you need to have lot of triggers. That is what. But without triggers and everything, I need to have a ready-made solution means. So you can go in for what? CDC. CDC means what? Change data capture, introduced in SQL Server 2008. It is also available in our Oracle and other databases. Clear? So this can be implemented without cracking our head, creating our own triggers and everything. We should be able to enable the database, and we can implement CDC. And CDC needs ADO.NET connections. It does not need OLADB connections, right? So if you know this, then definitely we can start with CDC. Am I clear? So did you understand why CDC is introduced? and where the lookup may fail, because lookup and merge always going to compare what? Always going to compare source data with the destination data. So the problem, if we have 50 million data here, if you have a 200 million data, comparing row by row is very, very difficult. So in the next technique, we implemented a trigger and we created a new table here, and the trigger is going to be inserting the records. Whenever we insert here, whenever you update, the trigger is going to be putting the updated records. You take this data, you perform insets and updates. You are not going to be comparing this and this. That is what is the beauty. By creating one trigger, you should be able to implement this. This is the best way. But without having triggers and everything, because triggers are very, very slow, because it's going to be getting fired every time when you insert, when you update, and it will create a lot of performance issues when you have a large amount of data. When you insert into the source systems, the triggers, when you have it, it will create a lot of nonsense and lot of performance issues, right? So in order to avoid that, we have a ready-made solution. The ready-made solution is called as CDC, change data capture. And with the help of this, we are going to be implementing. Now let me give a demo on this. So what is that I should do? First I have to go to SQL Server, create one database, right? So I would like to create a database. You can give any name. You can give any name. So I wanted to create a one database called CDC DB. You can give any name. You can give company. You can give Bhaskar, or you can give India. Any name you can give, doesn't matter. But I would like to give this name and use this database. Clear? So I have created a database called CDC, and I wanted to create, so the table, create employee table. So where in this database, right? So let me go, and I wanted to refresh and open. So we have CDC new. This is the database I'm talking about. And there is a table called employee table. Am I clear? Any doubts? Now we have to create a one more table, destination table, maybe here or maybe in the any other database. CDC also can be implemented in Oracle, so you need not worry about it, right? So we have to create one more table, dim employee. So employee ID, primary key, insert date, start date. Lot of things are available. Let me create this. So I have two tables. One is called this, and the second one is called this. So I wanted to insert some data here in the source level. I have some data, that is also fine. Now I wanted to implement incremental loading. First, if you want to implement, enable the CDC on specific database. Okay. So with the help of this command, clear. So execute sys spcdc enable db. What database I would like to enable? CDC DB new. So using this code, you should be able to execute it, and command completed successfully. You have to check whether it is enabled or not. Okay. So there is a sys.databases where name equals to this, and is CDC enabled? If it is enabled, you will get one. Have you seen this? So on this database, so already we knew sys.databases, right? So in this, you can see one. For let me take ibank database here. Okay, ibank database, when I choose this database, so I will be able to see a zero there. Okay, it is not enabled. Clear? I take some company database, whatever be the database that I have, so I can give the database name. I should be able to get a one. So in the company database, it is enabled. Company one database, is it enabled or not? Okay, it is not enabled. So you'll come to know in which database it is enabled. If you wanted to go for all databases, execute without where clause, and wherever this is equals to one, you can just get that data as well. Where is CDC is equals to one, so you can get in which databases it is got enabled. So in these three databases which is got enabled. Clear, guys? So this is how you should be able to get, right? CDC enable. That is what you should do if you wanted to implement CDC. This is one minus point because you need to have the permission to do this. Otherwise, you need to tell your DBA and to execute this. You can Google it and get these commands. Okay. So then we CDC enabled or not, we can check this. Clear? So then enable CDC on a specific table level. So what table I'm using? Source table is employee, and this is what is the schema. This is what is the stored proc I need to execute, and you should be able to execute this. This line of the code you will be able to get from where? From Google itself. Okay, simply write enable CDC in SQL Server. They will give you this code and simply execute it. It is one means it is enable, zero means disabling. That's it, nothing else. You execute this code and right, then you go to system tables where employee name is tracked by CDC, true or false. Okay, successfully done it. You execute on the table, it is done or not, it is done. Okay, we have one more table called dim employee table also, right? So is it enabled in this table? It's a zero. Have you seen this? So we are using system sys.table, sys.databases, right? So is it tracked by CDC? So this is the one you have to put. Star means remaining columns, right? For employee table, it is enabled, but not for the destination table. So these are the two steps I'm talking about. Okay, these are the negative points because with only SSIS you cannot implement. You need to go to the database level and you need to implement the CDC. Oracle is supporting. I think even MySQL and Teradata, most of the RDBMS is supporting. You have to use, enable options at the data source level. Clear? So that's it. So once it is done, you are now ready to take. You're now ready to take what? A demo. Let me create a new package. So let me have close everything. I wanted to rename this. So 17 demo and incremental. It is not incremental loading. It is CDC initial loading. Okay. CDC initial loading. So we have to load all the data. For example, if you have so much of data here, if you have so much of data, right, lot millions of data is available here. Let me forget about, let me remove all these things. So we don't have any data here. Okay, we don't have any data. The starting, you have some 100 million data is available. Clear? When you have 100 millions of data, you have to perform what is called as a initial load. Initial load means no comparison, nothing. So what we're going to be taking, completely take all the data and you're going to be dumping it here. So CDC comes with a two steps process. One is called CDC initial loading. Okay, initial loading, because so much of a data. The next one is called, you need to create one more package for the incremental loading. Clear? But now lookup and other stuff, it is doing incremental loading, full loading. If the data is not matching, inside, if it is matching, then update. So for lookup and SCD and merge, there is no initial loading, there is no incremental loading, right? Because if the data is not getting matched, then you insert. If no match means you insert. If it is a match means you update. That's what we were doing in merge and lookup. But here we are not going to be comparing anything, right? So CDC will have a package on initial load. In the initial load, all the data. So for example, I have two rows. These two rows will get loaded as it is. Then what data it is got loaded. So that is what is called initial load. So complete data that you need to have it. So this is what we're going to be doing. So next package, we're going to be performing CDC incremental loading, right? You have to run this and initially only once in the lifetime you need to run. So later you have to schedule the incremental loading only, because we are not talking about, 30,000 rows or 1 million data. We're talking about huge data. You will not be able to perform incremental loading from day one. You need to start the initial loading. Complete data will get loaded. And what data is getting loaded? the state, so we're going to be creating a table called CDC state table. So inside that, so it will write and when what time it got executed and what data got loaded. So it is going to be capturing some time here. So timestamp it is going to be capturing in this table. So this table is also automatically gets created. So as part of our solution, what is the table name? CDC state table. Clear? So it is going to be marking saying that this data has been loaded, and when it is got loaded, it is going to be having a timestamp column. So timestamp column will have some date and time when it is got loaded. So after this timestamp, whenever you modify this data, whenever you update the data, it is going to be capturing the complete information into one more table. It is automatic. Clear? So that is what you need to create. You need to create one more table called CDC state table. And what is the, whenever it is loading this, it's going to be capturing date and time, a lot of other things, what data got loaded, blah, blah, blah. Clear? So this one table we need to create, and what information it is going to store, that we need not worry about it. It is internal to that. Clear, guys? So that is what you need to understand. So so now I'm going to be taking a package called CDC initial loading. So when you go to control flow, Microsoft is giving with a lot of common tasks, and we have a lot of other tasks. As part of here, we have a CDC control task is available. So this is added in a 12 onwards. Okay, in SQL Server level, CDC is introduced in 2008 itself. But in SSIS, it is 2012 onwards, the support is added for the CDC, not before that. Clear? So SQL Server and you can do it, but with the help of SSIS, the CDC support is enabled at 2012 level. Clear? So you can go to other tasks, then you should be able to get CDC control task. Now, I told you, you need one .NET connection because without ADO.NET, it is not going to work. That's what I told you, right? CDC needs ADO.NET connection. Now, if you want to create a connection, you can simply go to Connection Manager, right click on this, and ADO.NET connection, OLADB, Flatfile, any connection you can create, you can use it. Or you can go and create a new connection and you can get it. So anything is fine, right? So you can create a new connection and it is saying ADO.NET Connection Manager. You can also click on new, create a connection there, or you can also right click on this, say ADO.NET connection. So you can remove if you have something, click new, and the server name is a dot. Now I wanted to use my database as CDCDB new, right? So this is the database I'm going to be using. Now click on OK, click on OK. Now click on OK. You can rename. This is what is called CDC connection, right? You can say CDC connection. You can give some name, double click on this, and it is automatically taken. Now we have some control operations. What is that initially we are doing? We are doing marking start load. Clear? So I told you we are going to be creating a table called CDC state table. So whenever you load the data from this to this, it is going to be marking some things into this table, saying that this is where this is the time this is getting started, and this is the time this is getting ended, and these are the rows got copied. Lot of information is going to be writing into this. Clear? So that is what is called here mark initial load start. Clear? So it is going to be writing where it is going to be writing into this table. Where is this table available? This table is not available as of now. This table will be available in this. We are going to be creating, right? So whenever it is going to be inserting the data, it needs some info. That info will get captured with the help of this variable containing CDC state. Okay, whatever it wanted to insert here, whatever it wanted to insert here, it is automatically coming from SSIS. Okay, that that we are capturing into one variable. Clear? So the variable name you can give XYZ, or you can give some name. So it is going to be using some variable, and some states it's going to be collecting it. So this information which is going to be storing in a table, this table you need to create. Okay, I don't have any tables here. I wanted to create a new table where, so as part of my database, the table name is called CDC state, and you need to run this code. Okay, when you run the code, it is created. Now the table name is called CDC state, and this is what you have to do it. Clear? So this is, it is what is called as start, right? So mark initial load start. Okay, so it is going to be using a table called this table, and which is going to be recording something saying that this data is being loaded, right? For example, you're loading some data, you need to write somewhere this data has been loaded, right? So where is that getting inserted into this table? So what is the table? Just now we created a table. Now when you go and refresh it, when you go and refresh it, you will be able to see one more table called CDC state table. It is having two columns, name and state. Clear? It's going to be getting the data with the help of this variable. What variable? So the variable also we created user CDC state, some variable, right? So this is what is called as mark initial load start. So this is mark initial load start. Okay, so you need to do it and control C and control V, copy and paste, right? So this you're going to be renaming that as end. Okay, so you go and you keep as it is and change mark initial load end. Clear? So in between, we are going to be completely loading data. So how can we load the data from one table to another table? With the help of a data flow task. You join like this, you join like this. So whenever you load, it is going to be writing some information into this table, right? And once that data is being loaded, then it is also marking here. So that is, we are not worry how it is marking, what it is marking, that you need not worry about it, but it is going to be marking saying that some data has been flown. Because when you run the same task at second time, it should not take the same duplicate data, and you should not load this data. It already knows that this data has been processed. Clear? So you need to know that. Okay, only one thing, that is mark initial load start here, and after the data flow, you need to say mark initial load end. And we are going to be using a variable, and we are creating a connection, and we have already created a table called state table that we are using. That. So this is what you need to do when you go to data flow task. Where is the data? Data is available in your OLEDB source. Now we can use OLEDB only for this two tasks purpose. I have created ADO.NET. So here I go, double click on this, connect a new connection. Now create a new OLEDB connection. Server name is dot, and what database I wanted to connect to, CDC new database. Click on here. So this is my source, and I wanted to use employee table as a source level table, right? So this is what is called my source. Okay, my source. Now I'm taking the data. Now I wanted to dump all the data without doing any transformation. If you wanted to do transformation, you can apply all transformation and do it. So again, take OLEDB and dump all the data here. So it is, again, I'm going to be creating one more connection. So connection to the same database, right? So you can give one more database or the same database, whatever you would like to have it, you can take it. So you can give this database, and already we created a table called dim employee table, right? So this table is available, and whenever we load the data, we have insert data also. Clear? So here we are going to be, this is what is our destination. Now how can we get insert a date? So we can use derived column transformation, and we can create a new column, insert date, right? And we can give get date. So go double click on this again and go to mappings, insert a date we have provided. Now it is saying some conversion. Why come conversion? Some data is being converted. So what is the data? So I see employee ID DTIT4, employee ID DTIT4, name string, name is unique code string it is. Okay, so I think I have created some different columns here. Okay, so if you see carefully, employee name is varchar 100 in the source level, and if you see, I have n varchar. This is what is called unique code, right? So the data type is not similar. So the varchar data, varchar here in the source level. So here it is n varchar data. I have to apply a data conversion also, right? Otherwise, data is not going to go. We knew how to apply data conversions, right? It's very, very simple. What column you need to apply? Only the name column. So I will say converted name. Converted into what column? It is unique code. So you press U, you should be able to have this. Unique code means DTST, WSTR data. Now you take this data, so you go and you supposed to give not the name, converted name you give. Updated records we're not going to be giving it here because it is initial load, right? Initial load means only inserting date will be there, so there is no updation. That's it. So go to format, auto layout diagram. So neatly diagram is got arranged. So this is what is called initial load. It will take all the data from here. What is the data size we have? 100 million rows we have. All the data is going to go here, and it is marking this table as a state table, and it is saying that and so time I have process this records. Clear? So later when you update something, it will know that. So after this time, whatever be the update happened, whatever be the insert happened, it knows that after this timestamp, whatever be the insert, whatever be the update happened, those records will be taken and performing as incremental loading. Clear? So we created CDC initial load, right? So we need to create one more CDC incremental loading. So that is also very, very important. Let me go and save, and I wanted to save and start this. Clear? So I will be able to get all this data to this table, right? So now 3 rows went there, 3 rows went there. So you should be able to see the data now. Data with insert date and there. And we also should see select star from one more table. What is the table name? States table, right? So this we have created. The CDC logic is going to be using the states table and writing something. So this is what is the state. We don't understand, but it can have some date and time, lot of things it's going to be putting there. If you see carefully, there is a date and time. Have you seen this? The time, date, everything it is going to be putting into this. Okay. Okay. This is what is called the CDC state. It is telling that, so I have processed this table so and so time, and after this time, whatever be the records got inserted into the source or updated into the destination will get dumped into the destination table with the help of incremental loading. So this is very, very important. So we have done this. Am I clear, guys? It's very, very simple. So the next one, what you need to do, you have to go in for demo number 18. It's very, very simple, not very complex. It will take another 10 minutes to complete it. Okay, so let me go here, rename. So demo number, this one. So incremental, CDC incremental loading. Okay, CDC incremental loading, that is what we should know. So we knew that you need to go to control flow, go to other tasks and get CDC control task first, right? So that is what we have to use it. Now double click on this. Now we need to perform the incremental loading. So We knew that we need one ADO.NET connection. Right click, ADO.NET connection. So if you want to delete, you can delete, create a new one. There is no problem at all. Server name dot, and what database I would like to use, this database, and you can simply rename this as a CDC underscore connection. That's it. So double click on this, automatically taken. Now it is not a mark initial load. It is, I need to set some range data. So these two things we have used. Let me use get process range. This is where I'm going to be taking the incremental loading. You need to use get a processing and a variable. So you need to create a one variable, and already we have created a table called states table, and it's going to be connecting to states table with this, and the state name is CDC state. So this is very, very easy. That's it. Okay. So this is what is called get processing range. So you can rename. Okay. So get processing range. This is a start. Clear? So it is going to be again logging whenever it implements incremental loading, it is going to be updating this states table. Clear? So you go copy this and you again paste this. Now this is what is called, you rename, this is what is called ending. Okay. So you double click on this. Now you go and change mark process range. This is what is called ending. Clear? Mark, this is starting, this is ending. This only you should change, remaining things as it is. Clear? In between, you need to have the data flow task for the incremental loading. You connect this, you connect this. So this fellow is going to update the CDC states table. And once it is started, this fellow is going to be updating CDC states table once it is loaded. So this is the, the state available in the CDC states table. Clear? So this already we have created. We are using the same thing. That's it. Now you go to data flow task. Now you have to use a source called CDC source, not ADO.NET or OLEDB. Earlier we have taken a OLEDB source. If you go, the first time we were using OLEDB source, clear? But now we have to use what is called as a CDC source, right? So this is what is the new thing added in SSIS in data flow task. So when you double click on this, go to CDC source and you can connect. So the source, so you can create one more ADO.NET connection. I can use the same thing, right? So this will be my source data. Okay, my source data, I will be able to go. I can give my source here, my source, and which table I need to connect it to. So I have to connect it to employee table where the CDC is enabled, right? And variable containing CDC state. I have created a variable called CDC state, right? So this variable I'm going to be using, and click on OK. So you just keep as it is, don't do anything here. That's it. It's very, very simple. So double click on this. Now source connecting to the the database, and which table you would like to take as a source, and CDC processing all modes I would like to have it. And I have a variable I have created. Where did I create a variable? So if you remember, you go, I have created a variable CDC state. Clear? So using this, it is going to be, putting the data into this table. Clear? So CDC states will be, stored in that variable. So it is going to be getting updated into this variable, this table. Clear? So that is what is the source, CDC source. Now, you have, if you go to common, there is a CDC splitter. So if you go to other transformation, there is a CDC splitter that you can use it. Where it is available, other transformation, you're going to be giving this data to the splitter. You need not do anything here. Automatically, it will split. So inserts are coming to one more Updates are going to coming to one more, and deletes are also going to coming to one more destination. So automatically it is going to be splitting. You need not write any code. Simply you can take now your OLEDB destination. In the sources we have CDC source, but there is no CDC destination. You can go in for OLEDB destination. You can simply take what data you would like to have it. So deleted data, inserted data, updated data, inserted data, I wanted to have it. So now you go there. Now you create a connection. So what connection? You can delete all of them and you can go in for the new connection if you wanted to have it. So you can create your own connection. So dot your connection to which database, wherever the database is available. Need not be CDC DB, it can be any other database. It may be in Oracle server as well. So I have a already table called dim employee table and mappings. So I need to give insert date, that is missing, right? So I need to have insert date I wanted to give. So I would like to give, how can I give insert date? If you're inserting any incremental data, the inserted date and time with the help of derived column, right? So I wanted to connect. Now give the inserted output here. Now you go, you say insert date. Is a get date, right? Now you need to convert, double click on this. Now everything is fine. This is inserted date, right? Update is not going to be happening here. So this is completely fine. Let me neatly arrange it. So this is for the data insert. Clear? So this is what is, you can rename this as a destination. Now I wanted to also update, right? Whenever the data updates, so updation can be done with the help of a OLEDB command. OLEDB command is very, very bad, but we can implement execute SQL task later. So CDC insert, CDC update. So you can go update, right? So how to update we knew. So to update, so we need to write a command. So in this table, we need to update the data, right? So how can we update? We know update dim employee set name is equivalent to question mark, salary is equivalent to question mark, and update date is equivalent to get date. Okay, and where employee ID is equivalent to question mark, right? So this is how we need to give. This is 0, this is 1, this is 2. So we need to write this command. But we know OLEDB command is very, very slow. So we go to destination. So then we can have this here and you can go to the column mapping. What is 0? 0 is the name. What is 1? 1 is the salary. What is parameter to employee ID? Done, done. So we are going to be replacing with the execute SQL task that already we discussed, right? So how to do that? So this we can capture into one more table. So that is a temporary table, and using execute SQL task, once everything is done at the end, what we're going to be doing, we're performing update operation with the execute SQL task, right? Because we know OLEDB command is very, very dangerous. If you wanted to delete the data also, we should be able to delete the data. So there is one more thing that is available for the deletion. Clear? Normally we insert, we update, we never delete, right? So that's it. Our package is ready. Now you go. So I have the same data. Now I want to insert some data. I would like to update Salman to Salman Khan. One data got loaded, and let me insert two more rows. Clear? Let me just check. I have two things, right? So data got modified here, Salman Khan, and two more rows got added here. Now I wanted to perform incremental loading, right? So don't run the initial load. Initial load is done. So you supposed to save and start. Clear? So with the help of state table, with the help of this table, it's going to be taking all updates. It's going to be updating it here. Going to be, inserted rows will get inserted there, which is not going to compare this table with this table at all. So that is the beauty about it. So, so let me execute, because first time we're executing, right? It will not get any data. So next time when you execute once more, right? If you execute once more, then it is going to be performing perfectly fine. So three rows, because the two rows are getting what? Inserted. One row is getting updated. Now let me go and check. Here we have Salman Khan. Salman Khan, it got updated. Two more rows got inserted there. Now let me update, John name to something else. So John name to John Kennedy. Okay. So I wanted to update this guy's data. Now I wanted to also update his salary to 2300, the salary of the third guy, right? Now I wanted to also insert one row, right? So the one row I wanted to have Kim, right? So let me execute this. Let me execute this. One row got inserted, and you have one update here, and 2300, and this is also one update. Now you should be able to run this. Clear? So now three rows again, you will have one insert and two updates. Clear? So you just go there and you should be able to run this package. Okay. So when you create a package, first time you run it, it will not do anything. But later on, it can perform incremental loading. That's it. Because it's going to be updating the state stable everything first time. Clear? So that is what is the beauty. It is going to be changing the state of the table, and internally it's going to be using. Am I clear? It is going to be performing a beautiful operations, and without comparing the destination table with the source table, it's going to be using a table called the CDC states table. That's it. So this is the data got updated. Salman Khan and this one, and even Harsha salary got updated. Now Kim, this is the new data got arrived. So this is what is the beauty about CDC. Am I clear, guys? It's very, very easy, and you need to have initial load for one package, and you need to have full load for the one more package. That's it. So incremental loading, initial load or full load is one package. Incremental loading with the CDC is one more package. So that is how you have to perform incremental loading. So when you have large amount of data, incremental loading can be done with the help of CDC is always better opportunity without using and lookup and other stuff. Am I clear? Thank you, guys. Any other questions?